Bismillahirrahmanirrahim. Previously, I suggested to you that there were three common ways of writing equations for lines, and the very familiar y equals mx plus b, and this, as you know, is the slope-intercept form because it gives the slope of the line and the y-intercept form. So this form is called the slope-intercept form, and that's pretty easy enough to appreciate. And we talked about how you graph these slope-intercept lines of equations that are given in slope-intercept form. Now, then the second and the third, there are two other forms that we talked about previously, and that's the standard form and the point-slope form, and that's what we shall talk about today. So, if you recall, the standard form of a line was something like this: ax plus by is equal to c, and this is called the standard form. Okay, so a linear function, a line, can be written in three different ways, and this is called the standard form, and this is called the slope-intercept form, and finally the point-slope form: y minus y1 is equal to slope times x minus x1, and this is called the point-slope form. And the reason it's called the point-slope form, of course, is because it gives a point that is on the line and the slope, and the point that it's on the line that it gives you is x1 and y1 in this particular equation set. And you have to know these, and in other words, you have to know that there are three common ways of writing equations of lines, or writing linear functions, really. And these are the standard form and the slope-intercept form and the point-slope form. The second thing is you have to be able to graph these, and last time we talked about graphing the slope-intercept form. And before if you graph these, first of all, you have to recognize that when a line is given to you in any of these particular forms. For example, if you're given y is equal to 2x minus 1, you have to recognize that this is a linear function in equation of a line that's given to you in the slope-intercept form, where the slope is 2 and the y-intercept is 1. And if you can't recognize that, then we be in trouble, as you say. So, and then similarly, you have to recognize when you're given an equation of a line in the standard form and the slope and the point-slope form. And if you don't recognize it, then again we be in trouble. So, for example, we are in trouble. 2x plus 3y is equal to 6, for example. So this is, you have to be able to recognize that this is actually a line. That's a equation of a line. That's a linear function. Okay. Now, if you can't tell that, and the difference between that and like a squirrel on the side of a street, then we are in trouble. I mean, that's the first thing you do is you have to recognize that this is an equation of a line. And in the same way over here, you have to recognize when you're given a line in the point-slope form. So if you're given like y minus 1 is equal to 2/3 times x plus 3, you have to recognize this also is a line that's given to you in the point-slope form. So that's one thing. Now I say, well, that's easy enough to do, and it is, and it should be. However, there are times when there's slight variation. These might confuse you. For example, if you are given something like this, y is equal to 3x. Now, a student might be confused. I mean, what is that? I mean, they might not appreciate that this is still a line. And this equation is y is given in this particular form. Y is equal to mx plus b. Well, where's the b? So, well, you don't see it. Well, it is there. It is 0. That's a line whose y-intercept is 0. It's like this, and the slope is 3. That's 3 over 1. That means you go up 3 and over 1 like this, and that would be the equation. That would be how the line would kind of look like in that sense. So you have to be able to recognize slight variations of these and not be so readily confused if there's a slight variation. In the same way, you have to understand that horizontal lines have equations that look like this: y is equal to 3. That, in fact, is a equation of a horizontal line that goes to this point. That's 3. That's 2 over here, and it's a horizontal line like this. Okay, and you also have to know that vertical lines have equations that look like this: x is equal to 2. Now this is an equation in the, if you were to graph this in the Cartesian plane, that would be a line that's a vertical line that goes to intersect the x-axis at 2, like this. So you have to recognize lines when you see them, and you also have to make sure you're not fooled by, and in fact, usually the simpler expressions of lines like this is a horizontal line that goes to 3, and this is a vertical line. All horizontal lines, they look like this, and y equals -2 is a horizontal line that goes to -2, like that. So that's another thing that you have to appreciate about lines. The vertical lines is like x equal 2 would be a vertical line that goes through 2, like this. And in the same fashion, you have to recognize slight variations of these as well. Today, inshallah, we shall focus on the standard form and the point slope form of linear functions or lines. Now, if you recall, I had suggested that if you're given an equation of a line like this, y is equal to 2/3 x plus 3, or let's say -3. Let me make this a -3. If you are given an equation of a line like this, okay, there is a strategy. There's a methodology of graphing these. First, you put the y-intercept over here like this, -3, and then you go up 2 and over 3 because that's the slope. So you start off at the y-intercept and you go up 2 and over 3 to secure yourself or get yourself a second point. And once you have 2 points, you simply just connect the dots like this, and you have your line. So there is a strategy for graphing lines that are given to you in the most common, the slope-intercept form. In the same way, if you're given a line in the standard form, ax plus by equals c, where a, b, and c are some constant numbers, there are some constant numbers, and x and y are the variables, there is a strategy, there's a methodology of graphing these. So let's just start with an example. So I have here, let's say 2x plus 3y is equal to 6. So this is, of course, a line that's given to you in the standard form. In this case, a is 2, and 3 is b. So a is 2, and b is 3. And c, of course, is 6 over here. So the coefficients of the variables, in this case 2 and 3, the coefficients of the variables represent a and b. As you can see, ax plus by, and then this constant over here is 6. Okay, so that's easy enough. So we recognize this to be a line that's given to you in the standard form. Now, how do we graph this? Well, the way we graph this is, how I like to think about it, is you make a baby table. It's like this. So you can graph lines, of course, using baby tables or tables. You can you can figure out a few points that are on the line. You substitute numbers for x and then get y. And then so you can graph lines using tables, of course, by generating a few points that are on the line. But to graph a line, you only need 2 points. You only need 2 points that are on the line, because 2 points determine a unique line. So what we do is, and I affectionately call this the baby table, because it's going to have only 2 points in it. So the baby table is not just any ordinary baby table, the baby table of the intercepts, okay? And that is, this is going to be a table of f(x) and y intercepts. So this is how you generate the baby table. So you're going to need, what you're doing here is you're trying to find 2 points that are on the line. Not just any points, you're going to find 2 points that are very special. And what's so special about them? Well, one of them is going to be the y-intercept, where the line intersects the y-axis, and the other one is going to be where the line intersects the x-axis. So I'm just making these up here. These may not be belonging to this line. So one of these points is going to be the x-intercept, or where the line intersects the x-axis, and the other point is going to be the y-intercept. So every line every line that's not parallel to the axis. For example, if you have a horizontal line, it's going to be parallel to the x-axis. It's not going to have any x-intercepts, right? Similarly, if you have a vertical line like this, right, it's going to be parallel to the y-axis. It's not going to have any y-intercepts, right? So anyways, any line that's not parallel to the axes or perpendicular to the axis will have x and y intercepts. Correct? Okay, so this baby table is designed to find those x and y intercepts. All right. Now, so this is the baby table of intercepts. All right, that's what I affectionately call this. So now, if you observe, every x intercept and every y-intercept will be special in one particular sense. So this x-intercept, the ordered pair that belongs to every single x-intercept of every single line, will have some x value over here, but the y value would be 0, because every point that's on the x-axis, the y value for that point is 0, because, you know, it's like this is 2, this is 1, and that's going to be 0, right? So every x-intercept will have a ordered pair where the y value is 0. That's going to be 0 for every x-intercept. And every y-intercept, okay, the x value will be 0, right? And you have some y value over here. So if I were to pick any point over here, from let's say for this particular line that goes to that particular point, or any point over here like this, right? These lines have y-intercepts. The y-intercept x is 0, and there'll be some value of y, and this y-intercept x will be 0 and some other value of y, right? So every y-intercept will have x value that is 0. And in the same way, every x-intercept, let me just draw a couple of lines here. Here's one line, and, you know, here's another line. If for every x-intercept, there's one x-intercept, there's another x for every line, there'll be some x value, but the y value would be 0. And there'll be some x value here, and then the y value would be 0 like this, okay, for every. So the characteristics of x and y intercept is that one of the ordered pairs, one of the numbers in the ordered pair will be 0. Okay, so again, the characteristic of the intercept is that one of the numbers of the ordered pair will be 0. So that's what we do in this baby table. We generate the x and y intercepts. So this is the baby table of intercepts. Let me erase this so we can actually draw the proper line once we are ready to do. So how do we generate the this baby table? Well, you draw this table out, and in the first column, you put a 0 over here and leave this blank, and then in the second row you put a y over here and leave this blank, and then you just have to find those values out. Okay, so so what you do is, here you substitute 0 in here for x, so you substitute that over here, and then you solve for y. So that's what we're going to do. So I'm going to substitute, okay, 0 for x over here. So I have 2 times 0. I'm going to substitute that over there, and then I have plus 3y is equal to 6. Now the beauty of substituting 0 over here, that this value just becomes 0, because 2 times 0, of course, is just 0, so that's just disappears. So that's just a 0. 2 times 0 is 0. And any number times 0 is 0. So then you're left with 3y is equal to 6, and you can just solve for y, divide both sides by 3, then you get y is equal to 2. So we get y is equal to 2. So you substitute 0 for x, and then you solve for y. And again, then you can say, well, then you substitute 0 for y, and then you solve for x. So you substitute this over here for y, and then you solve for x. So let's do that. So I have 2x plus 3 times y. Now the y is going to be 0 this time, and that's equal to 0, equal to 6, and then this will disappear because any number times 0, last time I checked, is 0. So that's 2x is equal to 6, and divide both sides by 2, x is equal to 3. Okay, so we got that. So in the first scenario, we substituted 0 for x and solve for y, and in the second scenario, we substituted 0 for y and solve for x, and here we have. Now we have the two intercepts. So this is the baby table of intercepts, the x and y intercepts. So all we have to do now is just to graph these. So 0, 2, and x is 0, y is 2. and when x is 3, y is 0. So those are the two intercepts. So that's 3, 0, and here is 0, 2. Now, to be mustahab, to have good mathematical manners, we should label some of these points. That's 2 and that's 4. That's 1, that's 2, that's 3, and that's 4, and that's -1, and that's -2, and that's the y-axis. So now I've labeled the axes. I have drawn the x and y intercepts, and then all I have to do is simply just connect the dots. Here it is. Ta-da! And there's our line. So, and that's easy enough. So, and if you wanted to, you can label the line, right? So you can label this line in the graphs. You can say this line is 2x plus 3y is equal to 6, like this. So how do you graph a line that's given to you in the standard form? Well, you make the baby table of intercepts. How do you make the baby table of intercepts? Well, you draw this out. You put 0 here for x and 0 here for y, and then you substitute 0 for x and solve for y, and then substitute 0 for y and then solve for x, and you have 2 points that you can use to graph the line. Okay, so that's how you graph a line that's given to you in the standard form. Okay, so let's talk about the point slope form. So here's an example of a line that's given to you in the point slope form. If you recall, the point slope form is this: y minus y1 is equal to the slope times x minus x1. This is another way of writing a line, and the other two forms were, of course, the standard form and the slope-intercept form. Now, the reason this form is called the point slope form, and you said, oh, that's kind of complicated, I'm not sure if I like this form. On the contrary, this is actually a very, very useful form in algebra, and hopefully when you take advanced algebra classes, you'll find this to be of extreme value to you. But nevertheless, so here is a line that's given to you in the point slope form. Again, I said the first thing you have to do is you have to be able to recognize that this is an equation of a line that's given to you in the point slope form, and it's nothing. If you don't recognize this, then you can't go very far. You also have to recognize some variations of the point slope form that you might find confusing. For example, if somebody gave you y minus 2 is equal to for example, just like if you didn't have x plus 3. Now, well, then this is still a point slope form, or you can add 2 to both sides, and then you have the slope-intercept form. But you can just recognize that, okay, the slope is 1. There we go. So, or more trickier forms. But the idea being that you should recognize the when you're given a line. So, as I've said last time, if you it may seem simple, but you have to feel very comfortable. Ax plus by is equal to c, y is equal to mx plus b, and y minus y1 equals slope times the quantity x minus x1. If you just simply write this like 3 times or so until there's more conceptual writings here are familiar to you and you're comfortable with these, it's very, very important. So a little bit of effort goes a long way here in terms of your appreciation of with these concepts. Okay, nevertheless, okay. Now, the reason this is called the point slope form is because this form gives you 2 things. It gives you a point. It gives you a point that's on the line. It gives you a point that's on the line. Now, this point does not have to be the x-intercept, does not have to be the y-intercept. It can be, but it doesn't have to be. It could be any ordinary point anywhere on the line. Okay, it could be this, right? But it doesn't have to be x or y. It could be any point. It's just like a random point that's on the line. So the point slope form gives you a particular point that's on the line. That is, this of all the points, this point is definitely on the line. So it gives you a point that's on the line, right? Doesn't have to be anything else special about it except that it is on the line, and it gives you the slope, right? So it gives you the slope right there. So in this particular scenario, the point that's given to us is the following. Now here you have to be careful, because there's a negative sign here and there's a negative sign here. That's where the students make most of their fatal mistakes, so to speak. I don't know what it is about negative signs that students just mess it up so easily. Man, you just have to be a little careful. It's like, if somebody's driving, it says warning. This is like school zone, you have to drive slow. It's like, okay, then you be careful. You heed the warning. The same thing when you see a negative sign. It's like, warning, be careful. Don't make the silly mistakes that other students do. So you just be careful. Don't make them silly mistakes. So look, y minus y1, x minus x1. So if there's a minus here, okay, this is y1. And if there's a plus here, you have to understand this is x minus minus 3. So it's negative 3 is x1 over here, okay? So let's figure out what the point is. The point that's given to us in this particular function is this. So the x1 is actually negative 3 because this says plus. In the form, this is a negative sign. So in your mind's eye, you have to say this is like x minus minus 3. That's how you got it plus. So this actually would be the x1. So the x1, in fact, the x coordinate of the point that's given to you is actually negative 3 and not positive 3. And the y1 is actually 2 because it says y minus 2. So y1 is 2. So that's possibly the most the fatal and most common mistake the student make when dealing with this particular form. So the point is, the other common mistake the student make is if you tell them what's the point that's given in this line, and they say, okay, it's going to be 2 and negative 3. It's like, what the, because they see 2 first, so they put that as x and negative 3 as y. I mean, no, that's not correct. X1 is over there, all right, and y1 is over here. So you have to make sure you don't make that silly mistake. Done this long enough, I'm just telling you all the things that students do. So if you're a smart student, you won't fall for these silly mistakes. All right, anyway, that's the point. And what's the slope? Slope is negative 1/2. That's easy peasy. And that's all you need to graph the line. So let's put this point on the graph here, okay? Let's have good mathematical manners. Let's label our axes here, x and y, and let's label some of these tick marks here. That's 2, that's 3, and that's 4, and then that's 1, and that's 2, and that's 3, that's 4. So I've been trying to set a good example for you, because you don't do sloppy work, man. Who does sloppy work, right? Let's not do sloppy work. So let's do excellent work. So okay, now we have labeled our axes, and I put label some of the tick marks. Okay, now and then you put the point on the graph. So negative 3 and 2. So I have negative 3, which is right here, and up 2 over here. So that point is negative 3 and 2. So that point is on the line. So that's what this equation, it gives you a point that's on the line. And then we're given slope, and that's all you need. Slope is negative 1/2. Is negative 1, that's down 1 and over 2, like this. Okay, that's down 1 and over 2. So that's another point that's on the line, and that's all you really need. You only need 2 points, because 2 points determine a unique line, one of the most famous postulates in geometry, right? So here we have our 2 points. You can get more points. The slope is down 1 over 2. Here's another point if you wanted to, and all you have to do is just connect these points here like this. Oopsie daisy, you don't want to do that. You want to try to make it nice and as perfectionist. Okay, here you go. Ta-da! There's your line over there. And if you wanted to, you can label this line. Because if you have more than one line on the graph, then you have to tell which graph belongs to which equation, like this. So there it is. We have labeled the line, and that's how you graph lines that are given in the point slope form. As a review before we finish, there are 3 ways to write equations of lines. The first is the standard form ax plus by equals to c, and the way you graph this is you make a baby table of intercepts. So here's x and y, and then you substitute 0 for x and you solve for y, and then you substitute 0 for y and solve for x, and you have the two points over here, and then you can use that to graph. So this is the baby table of intercepts, right? So that's why I call that. Anyways, so that's that. And then, of course, the easy, probably most familiar to you, y equals mx plus b. This is a slope-intercept form. The way you graph that is you put the y-intercept in the graph, and then you have the slope, and you're done. And then finally, we talked today about the point slope form. Y minus y1 equals the slope times x minus x1. And here you find the point that's given to you, and then you have the slope. You plop the point on the graph, and then use the slope to generate another point, and then you can graph. So today we talked about how you graph a line that's given to you in the standard form and the point slope form. I hope you appreciate it, and we shall elaborate on this inshallah next time. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.